Every 44 minutes, Earth receives a signal. It arrives like clockwork, an eerie 2-minute pulse beaming from 15,820 light-years away. Silent to the eye, invisible to the naked sky, but loud enough for our radio telescopes to hear. Like a celestial metronome, it ticks in the background of the universe, marking time in a rhythm we've never seen before. And it's coming from something that doesn't behave like anything we've ever known. In a study published May 28, 2025, in the journal Nature, astronomers revealed the detection of an extraordinary object named ASKAP J1832-0911. It was first discovered using the Australian Square Kilometre Array Pathfinder, ASKAP, radio telescope in Western Australia, an instrument designed to scan enormous swaths of the sky for fleeting radio signals. But this one? This one stood out. Not for its intensity, but for its uncanny regularity. ASKAP J1832-0911 pulses every 1,320 seconds, precisely 44 minutes. That's an incredibly slow rhythm for any known astronomical object. Most neutron stars rotate dozens of times per second. Magnetars, the highly magnetized remnants of massive stars, may slow down with age, but even the slowest among them rotate once every 10 seconds. This is glacial. It's a cosmic heartbeat stretched thin, and yet somehow it persists. The pulses are not isolated to radio waves. NASA's Chandra X-ray Observatory later confirmed that each signal is echoed in high-energy X-rays, suggesting violent processes are unfolding inside or around the object. That rules out many mundane sources. We're not dealing with a fluke or an atmospheric anomaly. This is something real, something physical, something astrophysical. The team behind the discovery includes scientists from the International Center for Radio Astronomy Research, Curtin University, and CSIRO, in collaboration with institutions in Canada, the United States, and South Africa. Andy Wang, an astronomer at Curtin University in Perth, Australia, and the lead author of the study, described ASKAP J1832-0911 as unlike anything we've seen before. This object has the mass of a neutron star, perhaps even a slowly decaying magnetar, yet its behavior doesn't fit our models. Neutron stars are born in the crucible of supernovae, compressing immense mass into a sphere barely 20 kilometers wide. Their magnetic fields can be 1 trillion times stronger than Earth's. They spin rapidly and radiate energy furiously, slowly dimming with age. But when their rotation slows, their energy should fade. They're supposed to go silent. ASKAP J1832-0911 hasn't gone silent. It continues to shine, consistently, persistently, every 44 minutes. So the question is simple: how? If it's old, it should be quiet. If it's young, it should be spinning faster. So is it powered by residual heat, magnetic decay, matter accretion from a hidden binary partner? Or have we just stumbled across something no one has predicted? Some scientists suggest it could be an ultra-long period magnetar, a theorized but never before observed class of stellar remnant. Others go further, speculating that we may be looking at the first member of an entirely new family of astrophysical objects. It might even be a transitional object, caught between being a neutron star and something else entirely. The signals themselves are clean, bright, structured, like lighthouse beams sweeping across the cosmos, but from a rotating lantern that takes nearly an hour to complete its turn. The pulses are regular, meaning the object must be stable. But what anchors that stability? Fallback disks, rings of dust and gas left over from a supernova, might be interacting with the star's magnetic field. This friction could help explain the slow spin or even power the pulses. Or maybe the object is caught in a dance with another star and we just haven't seen the partner yet. We've seen strange things before: fast radio bursts, gamma-ray flares, stellar mass black holes. But this one is different. It doesn't scream. It whispers. It paces itself, and it never misses a beat. Fast radio bursts last milliseconds and are usually unpredictable. Magnetars emit chaotic, irregular bursts, but ASKAP J1832-0911 is patient. It follows a rhythm with eerie precision. A 2-minute pulse, then silence, then again, every 44 minutes. It's like something ancient is breathing, and that breath may be more than symbolic. Each pulse represents a tremendous outpouring of energy, akin to millions of suns briefly igniting in a single narrow band of the spectrum. It's not just a flicker in the void, it's a cosmic event echoing from a buried core that somehow still refuses to go quiet. This is not the first time ASKAP has detected oddities. Since its commissioning, the telescope has uncovered dozens of transient sources, each one peeling back a layer of the universe's mystery. But none quite like this. The object sits in the direction of the Scutum constellation, hovering above the crowded plain of our Milky Way. It lies in a region rich with stellar corpses, gas clouds, and unresolved X-ray sources. A galactic graveyard where stars once burned bright and died spectacularly. And now something is whispering from among the ashes. It forces us to ask, could there be many more of these quiet sentinels out there, slowly rotating, beaming energy into space in narrow, nearly undetectable bands? Have we missed them simply because we weren't looking often enough or listening long enough? The implications ripple outward. If ASKAP J1832-0911 is part of a larger, hidden population, we may be surrounded by objects like it, slowly rotating, quietly pulsing, hidden in plain sight. Perhaps we've simply lacked the patience or precision to hear them. And now, with instruments like ASKAP, Meerkat, Chandra, and soon the Square Kilometre Array, we're finally equipped to listen. This mystery also reminds us how little we truly know about the death of stars. What we call end states may actually be just transitions, gateways to something stranger. Magnetic fields, rotational inertia, gravitational collapse. These forces interact in ways we're only beginning to model. And sometimes those interactions produce something that challenges all expectations. We may be looking not at the end of stellar life, but a bridge to something new, an evolutionary phase that links known astrophysical objects to a class we haven't yet named. The discovery of one might mean the discovery of many, and with it, the possibility that our universe is filled with ancient mechanisms, quietly ticking beneath our awareness. In the coming years, this object will be watched relentlessly. Scientists will run simulations, generate magnetic field maps, and measure changes in pulse structure with exquisite precision. If this is a glimpse into a new phase of stellar evolution, we may be rewriting astrophysics from the ground up. The signals may hold clues about the early moments of neutron star birth, or even reveal the life stories of magnetars too faint or slow for us to have detected before. They may help us uncover mechanisms that connect particle physics to galactic-scale dynamics. And so we are listening. In many ways, ASKAP J1832-0911 is a riddle that arrived pre-solved. It tells us the answer every 44 minutes. Now we just have to figure out the question. Somewhere out there, a dead star spins with ghostly patience, not rapidly, not chaotically, but like a celestial monk meditating in the dark, or perhaps a beacon, a signal, one that has always been there, waiting for a species smart enough or curious enough to hear it. So the next time you look up, remember, the universe isn't just full of noise. It's full of patterns, stories, messages, and this is just the beginning. Subscribe to join us on the next journey across space and time, because the cosmos is whispering secrets, and we're finally starting to understand the language.